Okay guys, welcome back to my channel. Now today we're looking at a very crucial topic in physics called circular motion. Okay, now first of all, what is circular motion? Look at the board. Now it is a motion that occurs in a circular path. Its acceleration is directed towards the center of the circular path. So basically, any motion that occurs in a circular path is called circular motion. And one key note there is that the acceleration of that object is always directed towards the center of the circular path. Now continuation. Now note, an object in circular motion rather, possesses constant speed, okay, that's magnitude, but varying velocity, that's direction. So when you're moving in a circular path, your speed, the magnitude of your movement is constant, but the direction is what changes, okay? I'm going to explain on the board like this. I have a circular path, for example, okay? Now, as it is said here, the velocity is always tangential to the circular path, meaning if I pick a point, let's say I pick this point A, and the guy is moving this way, we have our V to move this direction, velocity. If I pick here, it's moving this direction, velocity. If I pick here, it's moving this way as velocity. Now, what can you observe? You observe that the direction of the velocity is changing at different parts of the motion. However, the magnitude, the value remains the same. So if you have, for example, 2 meters per second here, it's going to be 2 meters per second all through the motion, okay, because the speed is constant, okay, but the direction, which is velocity, is changing. I'm sure you all know that speed is scalar, while velocity is what now? Vector. In fact, the one that has s is scalar and the one that has v is a vector. Now moving on, we then said that there's something we call centripetal acceleration. Now what is this? Basically, it is that acceleration of that object that is directed towards the center of the what now? Circular path. Okay, so that's what we call AC. Okay, and it's equal to v squared over r. It depends on the velocity and the radius of the circular path. So it's v squared over r. If you observe the formula, you can see they are inversely proportional, meaning the A and the arrow are inversely related. So if you increase the radius of circular path, you have reduced the acceleration. While if you reduce circular path, you have increased the what now? Acceleration. So the wider the circle, the slower the acceleration. And then the thinner the circle, the faster the what now? The acceleration. Okay, so we have done. Then recall that v equals to omega r, where omega is what now? The angular velocity, okay, or angular frequency. So if you put v as this value here, you're going to get AC as w squared r. So you can either solve for v squared over r or what now? W squared r. Now moving on, the next thing to discuss is what we call the centripetal force. Now because we have centripetal acceleration, we are also going to have what now? Centripetal force. Because remember, from Newton's second law of motion, in my previous videos, if you have not watched my videos on motion, please go back to watch them. Motion part 1, part 2, part 3. Okay, now Newton said that F is equal to ma, meaning your F depends on an A. So if we have what we call centripetal acceleration, then therefore we must have what? Centripetal force. So how to define it is the force directed towards the center of the circular path, and it keeps the object in the circular path. In fact, there's the other brother called centrifugal force. Okay, now centripetal force moves towards the center, while centrifugal moves out from the center. Now they are the same value, but just opposite in what now? Direction, obeying the third law of motion. To every action, there must be an equal but what now? Opposite reaction. Are we together? So now FC becomes what now? MAC, obeying second law of motion, MA. So AC because it's FC. Are we together? And then AC, remember, it's V squared over R. So we have F equals what? MV squared over R. Then you can derive further to get what now? M omega squared what? R. So these are the two things you must remember first of all for circular motion: the acceleration and the what now? The force. Now moving on, we have two types of circular motion we are going to discuss. The first one is the vertical circular motion, and the next will be the horizontal circular motion. Now, for the vertical circular motion, it entails whirling an object, okay, in this manner. So you take, let's say, a sling, like what David used to kill Goliath, okay, and you put a stone and then you whirl it in this manner, okay, like you want to throw. So this kind of motion is called the vertical circular motion. Why? It is perpendicular to the horizontal surface. That's the key word. For you to be in vertical circular motion, you must be perpendicular to the horizontal surface. So you have a diagram of this nature. So you hold the object here and then you roll. Okay, you roll, you swing. Okay, so let's say it moves in this direction. Are we together? Now, from what we can see on the board, I've helped you to bring out the forces. I will explain. Now, when you have a rope and an object, there's something you call tension that always acts inside the rope. Okay, so the tension in this system acts inside the rope. Now looking at the board, the tension at point A acts downward, the tension at point B acts inward, at point C acts upward, and at point D acts inward again. Now, how do we relate the tension of this system to the centripetal force and the weight on each point? That's points A, B, C, and D. Let's observe, okay? Now, quickly, at point A, what can we see occurs? Remember that the force that actually acts towards the center is called the centripetal force. Now, from the diagram, we have both the mg and the TA acting downward, meaning that the resultant of these two coming down is actually equal to what now? The FC. So we can say it means at point A, we can say TA plus mg, they are both acting down, must give you up the centripetal force FC. We are looking for TA, so we then say TA should be equal to what now? Okay, FC, okay, minus mg. Okay, TA should be equal to what now? FC minus mg. Now, what is FC? Remember, FC is just mv squared over r. So we can say TA should be equal to mv squared over r minus what? Minus mg. Okay, now if you factorize, you're going to get m, open a bracket, v squared over r minus g. Now this should be the tension at point E. Now quickly, the tension at point B, if you observe, the weight, the mg, will not affect the FC. Okay, because FC is moving inward, but mg is just going down, so it doesn't really matter. Now it means that at point B, the tension B is actually equal to the what now? The FC, because they're in the same direction. So we can say at point B, TB is just equal to what now? FC, which is mv squared over r. Okay, now quickly moving on, at point C, if you observe, TC is moving up, but mg is moving down. TC moves up, mg moves down. Now recall that FC moves up. So how do we get the FC? Meaning that we're going to have to do a resolution here. So between TC and mg, who do you think, or which do you think is larger? Okay, the answer is what? TC. Why? Because the object is still moving upward. So the force in the upward is more than the force on the downward. So it means we're going to do TC minus mg to give you the resultant force, which is FC. So we'll say at point C, we're going to say TC minus mg, okay, must be equal to what now? FC. So when you do your calculation, you're going to have TC to be equal to what now? FC plus mg. Okay, so therefore, what is FC? We can say TC becomes mv squared over r plus mg. Now, if you factorize again, you're going to have m, open a bracket, v squared over r plus g. This is the tension at point C. Now, lastly, the one at point D, to not waste our time, is just similar to the one at point B. Okay, so you can just say TD is just equal to what again? FC, which is mv squared over r. Now, you're wondering, they might ask you a question like, what is the maximum tension or what is the minimum tension? Now, how do you get that value? Quickly look at the board. Now, between TA, TB, TC, and TD, which would have the higher value? Let's observe. Now, looking at TA, to get TA, we are subtracting the weight from the FC, meaning TA should be lower because I am removing the weight from FC. to get TB, it is just equal to FC, no reduction. So TB is okay, but TA, remember, is lower, is lesser. Now to get TC, I am adding the weight to FC, meaning I am increasing. To get TC, it will be higher because I'm adding the weight to FC to get TC. And then to get TD is just equal to what now? FC. So TD and TB are the same, but TA and TC varies. Okay, so now TA should be the lower tension because I remove the weight. So to get the minimum, as they call in the question, to get the minimum tension, it will be what now? M into V squared over R minus G. To get the minimum, the lesser tension, while to get the maximum tension, it will be the one at point C, which is M into V squared over R plus G. Okay, so minimum tension occurs at point A, and remember, A is the top. Okay, so you can be told again that where does it occur? It occurs at the top of the circular part, while the maximum tension occurs at the where now? At the bottom. Okay, at the bottom. Or they might ask you, where is breakage likely to occur? Take note, breakage is likely to occur at the point that has the maximum tension, which is what? At the bottom, point C. Okay, so T min at point A and T max at point C, which is top and what now? Bottom. So moving on, we're going to be looking at the next one, which is horizontal circular motion. But this will be all for this video. Okay, so please, these are the things you must learn for the vertical circular motion. We're going to be solving questions after this series. If you've not subscribed, please kindly subscribe and share the videos to your friends that offer physics either in O level or in A level. See you in the next video. God bless you.